In this lesson, we're going to talk about the idea of storing data within the program. Everything that we've done so far has been the user entering information, and we haven't had the ability to store that information. But oftentimes, a program will store information within a data set of items that can be accessed at any time, and kind of similar to storing it in a variable without taking up the memory locations of variables. So we're going to talk about the idea of storing data within a program. So why might I want to do that? That's always good when data can be reused. So the idea of looking something up, maybe a catalog, information from a catalog might be stored in a data set, and so I can access it at any time within the program. The months of the year, the 12 months of the year, that's not changing. So rather than have references to that every time, we might want to just store that information in there. Data that would relatively be unchanging. So this is data that only the programmer can change. It's not data that can be changed by the user. It can only be changed by the programmer. Data that most likely does not need input. Again, oftentimes software relies on us, inputting a lot of information, but if I can gather a data set. In programming too, we talk about the idea of creating text files, that ability to read out to a file, but then also read from a file. And so this will be that sort of starting point for us to look at creating the ability to access information. So the keywords related to data storage within the program. We have the keywords read, which instructs the computer to read one or more values from a data statement. Data is the keyword to indicate where information values are stored within the program code. Restore is the keyword that will be used to tell the pointer to return to the start of the data set. So when we're using the read and data keywords, so let's take a look at a basic program. So here's an example of lines of code, and here you can see data stored in the program. Now, the data line, which is what you see in line 50, can be anywhere in the program. I could have it at line 5 in this example. I could have it at line 25. Oftentimes, though, for conformity, it's outside of the general program. Yes, it's beyond the end, but the computer knows when it sees a read statement, it's going to look for the keyword data. So it can be beyond the end, that terminating keyword of the program. So some things to keep in mind: we need equal number of data pieces as read in values. And so the idea here that I'm reading one value at a time. And when we look at the next slide, you'll see better what I mean by having equal number of data pieces as read-in values. But the key thing is that the data types need to match. So the variable that I'm reading into, so in line 10, I'm reading into variable A. It doesn't have a $sign on it, so it's implying that 10, 20, and 30 are going to be numerical values, versus characters 1 and 0, 2 and 0, and 3 and 0, but these are going to be numerical values. So the variable type that I'm reading into has to match the information in the data line. So here we can see that it's going to read A. So what it's going to do is, so every time a program starts, the pointer is sitting at the first element in the data line. And so it is going to read 10 into the variable A. What I'm asking it to do then in the program is to print 10 or A out to the screen. So it's going to print that 10. This one says to go back up to 10. So it's going to read. So the pointer is going to move across because 10 was already read. And so it gets destroyed. I can't access it directly again just yet. We'll talk about that a little bit later on. So it moves the pointer over so that the next time the read statement is executed, it's going to read the 20 So it's going to print 20 to the screen. So it's already read that. So as the program's executing, I can't backtrack. It's going to keep moving that pointer across the data set. So the next time that the word read is executed, it's going to, in this case, read 30 into A. It is going to print 30 to the screen. Now, in this example, I have it kind of an infinite loop because it's just going back up. So if I attempt to read again, there's nothing here. All right. If I attempt to read again, what's going to happen is I'm going to get an out of data error because there was nothing there for it to read. So we need to be mindful of that as we're reading from a data set because that pointer keeps moving across. So there is the potential of an error. So here's an example, as I alluded to in the last slide, the idea of having matching data types. I can read in multiple items at a time. I could even add more variables to this read line as I would need. Now, this is reading a string and reading a constant. So in my data line, I must have matching pairs of data. I'm reading two things at a time. So I have to be reading a string and a constant, all right, because that's how it's paired. So it's going to read Tom and age, 12. It's going to read 12 and store it into those variables, and it's going to print it to the screen. Again, I have it going back up. So it's going to read Jim and 18, print it to the screen, and I have it going back up. Now, again, there's nothing stored here at the end, so I'm going to get the out of data error. Even if I forgot to add a piece of data, and let's say I have Sam here, but I'm missing the value for the age, I'm going to get an out of data error. So we need to make sure that if, in this case, I'm reading 2 items at a time, I need pairs of data. If I'm reading 3 items at a time, I need groups of 3, multiples of 3 as far as data goes so that I can avoid an out of data error. So we want to be able to avoid some of these errors. And so we're going to talk about the idea of a data terminating value, but then how can I use loops to help me with that as well? So we'll bring back that idea of loops to feed in data from a data line. So we want to avoid the out of data error. So we're going to create a dummy value here, but then I have to test for it as I'm reading. So the dummy values are the EOD and the -1, usually something outside of the normal data set. Still, I'm reading 2 things at a time, and so I made sure that I have 2 dummy values. Now, I'm only going to test for one of the dummy values. I don't have to test for both. I just need both for the sake of reading because I'm reading 2 things at a time, but I don't have to test for both. So this is going to read name and age. So it's going to read Tom and 12. If name is equal to EOD, then it says to go to 50. Well, Tom doesn't equal EOD, so it fails the test and drops to line 30, which tells it to print it to the screen. It's going to go back up. It's going to read Jim and 18. Jim's not equal to EOD, so it's going to print Jim 18 to the screen. It's going to go back up, and it's going to read EOD and -1. If name $ is equal to EOD, well, it is. So since it's true, now it's finally going to execute the go to 50, which is the end of the program. So I'm only going to see Tom 12, Jim 18 displayed to the screen. I'm not going to get the error message. I can employ a for loop. Remember, a for loop is used when I know the number of iterations that I need. So if I know the size of my data set, I can use the for loop to avoid the whole idea of the dummy variable. So I have 4 sets of piece of data. So my loop's going to iterate 4 times, 1, 2, 3, and 4, while x is equal to those values. Now, something I also want to demonstrate here is that I did not put everything on the same line. I can put Mary and Liz up on the same line as Joe and Tom, but I wanted to demonstrate to you how this works when I have multiple data lines. It is always going to look for the first line. No matter how I have the data lines dispersed throughout my program, it's always going to look for the first occurrence of the keyword data. This is going to read name and age, so it's going to read Joe and 11. And remember, the pointer moves as it reads. So it's destroying the information that's read. It's going to print Joe and 11 to the screen. It says next X, so X is equal to 2. It's going to read name and age. It's moving the pointer along as it's reading, and it's going to print Tom and 16 to the screen. It says next X, X is equal to 3, so it's still within the range. And it's going to wrap around to line 60, and it's going to read, since it's indicated as a data line, it's going to read Mary and 14. It's going to loop back up. It's going to read Liz and 15. It's going to say next X. 5's outside of the range, so it is not going to read again, so I don't get the out of data error. But one by one, it will print Joe 11, Tom and 16, and so on. But the key thing to also understand is in this example, I had 2 data lines, and it just keeps picking off the data as it's reading it, and it will wrap around to the next data line as it is, reading through the data. So it's important to understand that it's not going back to the beginning of line 50, and I can't tell it to do that. Okay, later we'll talk about the idea of restoring the information, but it just keeps picking them off one at a time. I can also use a while loop, remembering that they are interchangeable. They just have different characteristics. So this one, I have the dummy variable incorporated back into it. While name $sign's not equal to the EOD, it's going to read name and age. So it's going to read Joe and 11. It's going to test to see whether or not Joe was equal to the EOD. Joe's not, so it drops to line 40, and it prints Joe and 11 to the screen and goes back up. As it reads through, again, it's destroying the data as it's reading through. But once it reads EOD, name $sign's going to equal EOD. And I told it to bypass the printing so that we don't get EOD. That's not part of the names on the list. And I told it to go to line 50, which will come back up to the while statement. Well, it's not true that EOD is not equal to EOD, so it will fail the loop on the test and drop out of the while loop. So it will not print it to the screen, but it will use it to test for the end of the data set. So we can see that it works as the for loop worked. So this is good when I don't know how many pieces of data. Let's say it's a really large data set. All I have to do is throw, some dummy value at the end of the data set so that I know at one point where it is without having to count all of the pieces of data.